Hello, in this video we will be seeing how to create a PCB using Kicad open source tool. So first of all we will be placing components. So for that we can simply press A, and here we will be using an LDO which is AMS 1117 with 3.3 volt. We also need some USB port, USB micro in this case. So let's pick one.
We also need some capacitors, the polarized one, both in input as well as in the output side of this IC. So we will be using polarized one as it is mostly recommended to use the polarized one. So we will be using this one, or we have two options here, so anyone we can pick. Now we need a ground, so let's place anywhere in the circuit. We also need an LED in the output side for the basically for indication that our circuit is working. So we will be placing one LED, and then we also need pin header to connect the external device, like maybe ESP8266 or any other thing. So for that we will be using pin headers. So there are two types. In the connectors we have two things. One is the socket, another one is the pin header. So inside connector we can easily identify or easily pick that thing. Over here we can see it is 1 times 02 pin. That means one row and two column. So let's place anywhere in the circuit again, and then we will be. Now we can also remove that GND letter and that is written here, because we know that it is the ground. Now we have everything available in our circuit. Now we can um, adjust those components so they can take they should look aesthetically pleasing, as well as they should consume less space. So after um, adjusting adjusting them, let's press W in the keyboard and we will get the wire. Now connect shield and ground, and we can um, we can place one ground symbol here, and then let's connect the other um, the other components. So here we have connected the input and then the output C2, the capacitor C2. Then we also need to connect the LED, and if we press X in the keyboard, this will horizontally shift or rotate our components. We can also enter R to rotate the components, and also place Y, so we can play with those keywords in order to get our desired orientation of the component. Now connect the pin header, and these are the ground, so we will be connecting all the capacitors as well as the IC's ground. Now connect the ground pin of the pin header to this connection to the ground, and we will be connecting this ground symbol somewhere in this circuit. We can simply drag and drop, I mean drag that components towards the junction and then drag. So I think this is our circuit. I think our circuit is completed now. Okay, here we need one ground to for the LED. I will be dragging this ground little bit lower, and we are done. Our circuit is almost completed, but still we do not have the value of the capacitors. Now let's you can see we do not have the value of the capacitors now. So let's use this IC number and make a Google search. We can also even use some AI models like Gemini or even ChatGPT to get some value. But it is recommended to use the datasheet of this IC. And again, there are lots of different manufacturers of this IC. So again, that is also they should also be considered while designing that um, designing that hardware. So now let's download one and try to read the data sheet in order to get some information uh, regarding the capacitors that should be connected. So let me enter the code in order to download from this alldatasheet.com. Now we have downloaded that PDF, and let's read some pages in order to get some valuable information. This is regarding that adjustable output, which is not that is not something we are making today. So I think the information is not given here. So we can also search different websites. Okay, after some research, I found I should use like 10 microfarad capacitor here in the input side and 22 microfarad capacitor value in the output side. So let's put that value, and we are done. Now we can assign the footprints, and since we are using the through hole components, so we will be selecting THT, and over here we have so many information, so many options to choose from. Here we have axial and radial. So I we will be using that radial thing, and similarly for 22 microfarad we will be again selecting the radial one. Let's do one thing. Let's make a Google search and try to find out the diameter and the pitch of those capacitors. So here I'm selecting one, this 66 number one, which is diameter 10 mm and pitch 2.50 mm. Pitch means the distance between two leads of those capacitors. Later we can also we can edit this thing. Now let's pick one LED SMD version. It would be better to select 0805 one, or the hand soldered one. I found 0603 is quite small, and it is very much difficult to solder. So let me select that. Okay, now let's pick the USB micro. Now we need a pin header, one row and two column. So over here we have this 2.5 mm pitch, and I will be using this 2.5 mm one. This is quite common. Now we have here horizontal and vertical. We can, it is our choice, but I will be using this vertical one, and then we are done. Now we can put a box, make a box by pressing this if we press I in the keyboard, this will give us a line. We can draw it, some kind of line, and we can put everything inside this box. And if we hit escape, this will go. Now simply double click and drag. Now our box is done, and then again we double click and drag. So we can also adjust the size of this box, and press this T button, I mean T icon, and then we can write anything, power supply in this case, and this is done. Now our schematic is complete. We will now turn this schematic into PCB. So we will select this option, update PCB from schematic. This will open a new window, PCB window, and we will be routing, we will be adjusting the components and routing this. Before that, we need to update the PCB, this update PCB button, and save this report.txt file, and we are done. Now we have these footprints. We need to adjust them. We can also see these components are interconnected by this some kind of wire things. I think this is called a net list. um, Let me know in the comment section. Now we will be placing those components based on our wish. This is the pin header, and this is the LED. So after placing all these components, we need to route them or connect the wires, basically the PCB traces. So let me adjust them first. Here I am verifying the dimension of those capacitors, the exact dimension and the pitch. So I'm referring some articles here. Over here, in this description section, it is for 22 microfarad, it is diameter 10 mm and pitch 5 mm. So I will be selecting that exact component from the Kicad components list. So simply we can go to this schematic editor and double click, and then select those library icon in which is in the footprint row, and here we will be selecting diameter 10 and pitch 5 mm. This is the right one, so let's select this. Now let's also find out the dimension for 10 microfarad capacitor. From size we mean the diameter and pitch. So over here we can see for 10 microfarad the diameter should be, usually it is 6.3 mm, and pitch is 2.5 mm. So Again, double click on that symbol and go to footprint and click the library icon, and from here we can select 6.3 and 2.5 mm. So we have selected it. Press OK. Now our schematic is complete, so we must save this and go to the PCB editor and update PCB. Now let's define the outline of this PCB board. So for that we will be selecting edge cuts and we'll draw a line. We can also use the rectangle, but let's select a line, and here we can see this L gives us the distance between these two dots in mm. So this is 74.47 mm or 7.4 centimeter. Here our rectangle is complete. We can also edit the rectangle, I mean press this and drag to get a perfect rectangle. So double click it and delete. This is not required. Double click and drag. So this is how our rectangle is complete now. Now in the back side of this PCB we will be add field zone. So for that we will select this add field zone and then select the ground, and okay, for clearance we can also edit this, but let's keep it as it is and then press OK. We will be covering the entire board, selecting the entire board, and once it is done we can right click and select close outline. So then we can enter B. This will fill zones in the backside of our PCB. So now we can check that simply by clicking Alt and 3 in our keyboard. This will create this PCB 3D viewer. Over here we can see, although we do not have this J1 component, which is the PCB, which is the USB micro, we can also download the STL file for the USB micro and add that for the component. Well, now in our PCB editor, let's run the DRC to check if we are getting some errors or not. So I think we are not getting any errors here. Now at this stage, let's define some width of the PCB traces. So later we can use that while routing the front side of the copper, I mean front side of the PCB board. So here we have selected selected the front side here, and we will be routing this. So in order to run this, I mean route this PCB, simply place the cursor to that exact component and hit X keyboard in the keyboard. So this will route or create a PCB traces. Here we can also select the different width of the PCB trace, and we can start routing them. Now let me displace the LED D1 because I'm not happy with the placement of this component. So let me try where I can put this LED. I'm doing this in order to not use any bias. because this is going to be handmade and I do not want to use any copper wires. Okay, now our component placement is done. Now select the component and hit X in the keyboard. So let's start routing again. We can select the trace width from the left hand upper side of this drop down, and we can simply start routing this. And again, if we double click and drag, so um, we can edit that PCB as per our needs. Now I think our PCB is done, but please note the ground, all those grounds are still not connected. We can see we still have this netlist kind of thing. Now let's see the 3D viewer. In the 3D viewer, we can see we have some traces in the front side as well. Now let's try. Okay, so let me add these two grounds, connect them. So I am using the 0.5 mm width of this because the pitch of those USB is very small. So for that reason, I'm using 0.5 mm width. And again, I'm using the 8 fill zone in order to, I mean, in the front side of this copper of this board. So it is very easy, as we have also learned in the beginning. So for that, we need to press that add field zones, which is available in the right side of this Windows menu, and select the outline and simply press B. This will um, create that field zone. And let's again see in the 3D viewer. In the 3D viewer, we can see we have this thing. Okay, for the reason for using this field zone, uh, why I'm using this, the prime reason for this is to save some time while etching the board in ferric chloride, because this is the chemical treatment and needs quite a lot amount of time in order to etch the board. So that is why I'm using this method. Although this is not required because we are not working in RF hardware, which is high frequency waves, but still I'm using this because to save some time while etching this. So I think this is done now. So our board is complete.